Welcome to our talk. This is on melting icebergs. What we're going to do is we're going to take a big chunk of data from Kafka, and we're going to represent it to downstream processors that are aware of Iceberg table format, and we're going to do it without moving any data. That's the exciting bit. So just to get an idea of who we've got in the room, stick your left hand up if you're experienced in Kafka. And by experienced in Kafka, I mean you know how you've run a producer or a consumer before. Like, there we go. When I say experienced in Kafka, they go, oh, Kafka's scary. I don't know if I know anything. No, like literally, consumers are fine for us. Keep them up, by the way. Stick your right hand up if you're experienced in Iceberg. And by that, I mean you can spell iceberg. Yeah, there we go. That's the kind of level that we're heading for. Okay, so we've got lots of experts in here, so I don't need to do any explanation. That's great. So a short overview of what we're going to do. We're going to set the scene a little bit. We're going to go why Kafka, why Iceberg, and why now. Those are really the most important things that we need to cover in this talk. We're then going to go a little bit of a technical deep dive into Iceberg, including the diagram that I've seen at least 4 times today. So you guys will also have seen it at least 4 times today. We're going to do how we did it, which is largely unique, not seen it anymore, how we do Iceberg without actually moving any data. That's the trick to it. And we're going to give you a demo of that working, and then we're going to have a short talk about what opportunities that generates. So diving straight in at the beginning, if you're going to adopt a new data set or build a new pipeline today, there's no way that you're going to think about it in isolation. You're not going to think about it as this is a purely analytical task or this is a purely operational task. You're going to be thinking about it as a data engineer or as a back-end engineer or as a guy who wears a lot of hats, because there's a lot of those around at the moment. A guy who accepts new data being ingested into our business and flows it all the way through to where it can be used for reporting and strategic decision-making. On the way, it may power your web apps. It may, if you're Uber, it may move your little cars around the application. But we're looking at this flow from end to end. And that creates a number of technical challenges. For real time, you're not going to get the experimentation that you like. We're all big Kafka fans here, and we know that it's pretty iterative and pretty additive. Not really great if you just want to dump a slice of data and start messing around with it until you can achieve the goal that you want to achieve. It's also not very discoverable. I hesitate to do this because I do this every time. I've done 5 conferences in the last 5 weeks, and not once has anyone put their hand up. So please, please, somebody, even if you're lying, put your hand up for me and don't break my heart. Hands up if anyone has Kafka topics in their data catalog. I know you're just doing it to make me feel better. But yeah, really? Oh. You are my best friend ever. Thank you. Thank you so much. Up until now, that was 5 versions of this talk without 1 hand going up. Yeah, nobody cares about the operational side of their business when it comes to cataloging and governance and things like that. It's improving, but not fast enough, in my opinion. And lastly, you've got small window sizes. Kafka's still viewed as a pipe, which means you're looking at 7-day retention, something like that. Not enough to be able to provide the kind of analytical capabilities that we look for from our batch systems. Batch has got the opposite problems. Ultra high latency. So and by latency here, I'm talking like time from data point creation to availability for decision making and reporting. I was talking to that's typically sort of days. Hours if you're good, days is normal, the way we're looking at this. The other thing is setup time's really, really high. I was talking to a very, very large multinational bank a few weeks ago, and they were realistically saying that a new data pipeline from inception to actual productionization and GA is measured in months there. Not like literally months. And they weren't unhappy about that. They were like, that's just the time it takes to go through all of our flows. And it's also very rigid. You have a table structure defined in the analytical view of your business. And if you want to evolve that to meet what's changed on the data generation or on the operational side, that's a non-trivial task. It's a difficult thing to do. So where we're converging to is this. There's basically an artificially created wall between the operational realm in your business and the analytical realm in your business. The typical models are to develop in the operational realm first, then go, well, maybe someone from the analytical realm will request something, even though because there's no discoverability, they have no idea it exists, and then build in the analytical realm. It's painful, but I mean, I've made a career out of it, and I know a lot of people that have made a career out of it, so it's worked up until now. But I think with challenges, and I've got to mention the two-letter buzzword, the AI challenges, the most recent challenges, it doesn't work enough anymore. What you need is one converged system that you can use operationally to power your applications and analytically to power your more strategic things. You can see from this diagram that there's two ways of achieving that. Firstly, you could take your analytical system and you could teach it how to be operational. That's not what this talk's going to be about today, but it's a really, really legitimate way of looking at things. A good friend of mine, Stan, the Kafka guy, look him up on LinkedIn, has done a whole series about how you could use Postgres to replace Kafka, just by inserting into Postgres tables and selecting out of them again. It's a legitimate argument. It's not one that we particularly like, but it's a way of doing it. We like going the other way. We think operational systems are really, really good at what they do, and it's easier to teach them how to become analytic systems. So the rest of this talk is going to be on how we taught Kafka to be an analytical system. And no one's piped up or thrown stuff at me yet, but somebody in the back normally tries to throw stuff and say, that's not what Kafka's for. I'm not going to spend a lot of time on this slide, but there's a whole load of things that Kafka's not been for over the life of Kafka. Right. Turns out it's doing all of them at scale in very, very large organizations today. So when we say storing a large volume of data in Kafka is not what it's for, yeah, up until now it wasn't, but now it is. That's what we're going to do. We're now going to store everything that we want to use in our analytical realm. We're going to store that in our operational realm so that it's ready to be used for analytical purposes. Just greatly expand the amount of data we store in Kafka. And why can we do that now? I said this was going to cover why and why now. Most importantly, there's been a big, big shift in the Kafka world to cloud-native storage, to cheap, massively scalable object storage. And once you have that, I'm going to spoil the next 3 slides for me, but once you have that, the end result is infinite retention. Why would you ever throw any data away if it's this cheap and this easy to store it? So let's just have a quick history lesson. And we go back a year, literally only a year. Kafka was a super fast disk-based system. We stored everything on spinning disks. We handled all the replication and resilience ourselves, and it was super quick and scarily expensive, like crazy expensive compared to competing systems. And that created some uncomfortable conversations. As a business user, I come and say, look, I need to store 2 years of data for GDPR or something like that, right? And my Kafka operator would say, hell no, you're not going to do that. That will cost me an absolute fortune. Do you realize I've got to replicate that 3 times and store it on these really expensive disks? What you'd end up with is that Kafka being reduced down to the dumb pipe it was designed to be, and the rest for the long-term retention, you'd offload into another system and introduce all the cost, complexity, and consistency issues that come along with doing that kind of ETL. About a year ago, we merged Kit 405. Kit 405 gave us tiered storage. It gave us a hot set of very recent data that we could use to serve our operational applications. And it gave us the ability to offload the colder data into very cheap object storage. Suddenly, cost is no longer an issue. That's not true, by the way. The hot set still needed to be replicated, so it still cost a bit. But the principle was there, finally. This principle of having a much, much longer retention and a cold set of data in Kafka was born and was used. And it switched the decision. My business user can come along again and say, I need to store 2 years of data, and I think a little bit harder about telling him to go away and put it in Snowflake instead. That's where we're at now. But we just came from Current London, which was about a month ago, and the next generation is all object storage based. I put 3 different approaches that are currently available for you to try here, but there's many, many more. Right? If you take, there's like the warp, stream, and buff approach where everything is object storage. There's a kip out at the moment to merge like a choice between whether we want to use object storage or disk, or there's many different approaches to how to do cold storage in a similar vein to the way tier storage used to work. But the theme that I want you to take away from that is that object storage is now the core component for Kafka. That means storage costs have become negligible. Resilience has become a problem for Amazon to deal with rather than a problem for us as Kafka operators to deal with. And it's made the most important shift that we're going to cover in this talk, which is that you don't want to think about retention anymore. We've changed the argument from how small can I get my retention to why on earth would I ever throw any data away? Why can't I have infinite retention on every topic in everything in Kafka so that everything that comes in is immediately stored and available for use? So what we've achieved, and this is, I used to say this was for the future of Kafka. This is not, it's here now, is that we have Kafka as one consistent store for online and offline data. And as data engineers, we've been trying to build this for about the last 2 decades. So it's really, really exciting to see it finally coming together and actually happening. Yay. Nice round of applause. Yeah, that was wonderful. But, and there's always a but it's not enough. What we've now done is we've landed the data, so it's ready, but we don't have access to it. Produce, consume, pub, sub, whatever you want to call it, is not a pattern that works well for analytics. Anyone here use KSQL? Anyone ever tried to run an ad hoc KSQL query? No, you'll know what I mean. Anyway, if you try and do PubSub with like ad hoc queries or something like that, you end up with a huge amount of read requirement that just isn't practical to create an interactive system. The performance just isn't there. What we need is an access pattern that's a lot more friendly for analytics, and we also need a way of surfacing our Kafka data that's much more friendly to the lake. And why not Iceberg? So I'm going to hand over to Roman now, who's going to take you through a little overview of Iceberg and then how Kafka and Iceberg can meet.
Hello, I'm Roman, and let's go into the next slide. Oh, you already spoke. So what is Iceberg? Apache Iceberg is an open table format for huge analytics dataset as per Apache Iceberg webpage. But it adds kind of tables, surfacing data as tables to compute engines like Spark, Trino, Presto, Flink, and others. What's important, what it is not, it's not a database, it's not an engine, it's not really a service that does something for you. It's a set of specifications and libraries that other services use to read and write the data in the same kind of manner. What it enables is, where's my slide? Okay. Yes, it consists of different layers. So we have Iceberg catalogs that manage the metadata pointer, and then the rest is the layers of metadata that describes the layout of the data files sitting somewhere in the object store. The metadata files themselves sit in the object store, so they can be accessed independently by, say, Spark process running in one place, Snowflake running in a different place, something else, Trino or whatever client running in the third place. All they need to do is synchronize through Iceberg catalog to enforce the right asset transactions and things support on the write pass. And on the read pass, what is the latest version of the tables that I'm reading. So basically what it enables is separation between storage and query execution and the compute, going through catalog for the synchronization of writes and reads. Now, how did we do it? How can we land Iceberg on Kafka or show it? We can go and use a JBob. Not this JBob, but this one. So if you look at data on Kafka as just a bunch of bytes, it can be bytes on a disk in object storage. Why not on Kafka? Kafka characteristics are that it's good for sequential reads. It has rudimentary data organization. You have topics that group the events, and rudimentary data indexes, again by offsets and timestamps, and sharding on Kafka partitions. So that kind of resembles a file system or object file system a little bit. we can reuse those characteristics to build kind of projection for Iceberg. What do we need for that projection is we need to surface tables, schemas, partitioning, the Iceberg partitioning, basically the data layout, data distribution information, and the data itself as Parquet, Avro, or Orc files. So we can map Kafka units to Iceberg units quite nicely by mapping clusters in Kafka into namespaces on Iceberg, topics to tables, messages to rows, and then event fields or message fields as individual columns. We have that kind of topic table representation duality. Again, it's kind of familiar for people from Flink and so on, like the representing topics as tables is quite often concept. Now, if you take building blocks like Iceberg catalog that surfaces a metadata, and then a storage gateway that can surface S3 kind of object store, and then the Kafka itself to provide the metadata for us, we can build a system that batches Avro file, records into container file that we can represent at the runtime as over like a fake S3 compatible file system, so that we can at runtime serve the data that sits on Kafka as a bunch of files that we can then supply the metadata around for the Iceberg compatible engine to read. So Avro fits very well for us because Iceberg supports Avro alongside Parquet and Orc, and Avro is one of the well-supported formats on Kafka itself. The only difference is that in Kafka, Avro is like per message encoded, but there is a different encoding that supports the container files. So we can strip the magic bytes on the per message encoding, stitch them together into blocks, and serve that as a batch file that actually stitches like thousands of offsets, thousands of events as a single file that fits better for Iceberg type of representation. So we don't need to do any re-encoding really at that point. So it fits well into like at runtime produced projection. And then we can take the same layers and rebuild them ephemerally. So we have our Iceberg catalog that at runtime queries the Kafka metadata to know what the latest state of the topic is, then builds out intermediate layers of metadata files, and serves them again at runtime over the REST endpoints that represent compatible endpoints to S3 straight to the engine. So again, the point is that it's all ephemeral, it's all computed at runtime during the query execution. So on one side, it looks like S3 interface with Iceberg catalog over it, but on the other side, it's read directly from Kafka at the runtime execution. And here's our flow. So we have an analytical application, for example, Spark SQL. It goes and tries to query a table. At that point, it loads a table metadata, at which we can query the Kafka from our Iceberg gateway, and then resolve the metadata files, serve them back to the analytical application, and compute the data files, chunks of offsets that we need to represent as data files back to it. Again, the really important point is it's all runtime, it's all ephemeral. We don't store those files anywhere. We just take the range of offsets and are saying offsets from 1000 to 2000 is a file called 1000 to 2000.avro that we serve up. Yes, basically that. That gives us partition-based data pruning, where we can do the partitions on Kafka message timestamps with Iceberg date or time transforms applied to it. And then we can do the partition-based pruning on message keys as well, because Kafka data is already partitioned by message key. The only caveat is that Iceberg uses different murmur algorithm on hashing for bucket transformations than Kafka does. Kafka is using murmur 2, Iceberg is using murmur 3, so we need to configure producers to use the same bucketing algorithm, the same hashing algorithm on Kafka side to make the partitioning to align. Otherwise, your data distribution won't align, so you can't really apply it that way. But it's very minimal overhead when it's not in use. All the compute is happening during query time. There is nothing that needs to run in the background. There's nothing that moves things in the background ahead of time. It's just whenever you query, the query runs against Kafka, pulls some data from it, computes the metadata that needs to be served, and sends it back alongside with the data. Now, we could add indexer. Then during the metadata build for the tables, we can use the index data from the indexer to surface different kind of partitioning and data layouts, more smart representation of data distribution. So basically what that add is, if we have indexer running there and reading our topic as we write to Kafka, it can build up information about the messages on the topic inside the indexer. So when we are serving it, we can serve the partitioning on non-key, non-metadata fields, but on actual message content. So let's say our topic has, I don't know, orders that have 5 different categories, and as we index, we can store the information, which offsets contain which categories. Then when we serve the data, we can serve the data partitioned by those categories to the Iceberg engine, so that whenever it runs a query again, it can prune out categories it doesn't need when filter criteria includes a category of orders in the request. And then calculate the column statistics for like max-min distribution of values against the slices of data in Kafka itself. So there's a lot of kind of technical stuff. I'll go and do a demo that will make it a little bit more understandable, hopefully. And let me switch. It's pre-recorded, just not to rely on the gods of internet and things. But what we have here is a PySpark environment with some Spark SQL running against the Iceberg projection. So we set the Spark session, set the Iceberg catalog to use, and run the show tables, which lists the topics that we have in the Kafka environment in this case, and describe one of them. So that shows us our fields in the events, plus the Kafka metadata, like Kafka offset and timestamp, plus partitioning done on the transaction time field as hourly chunks. We can query some metadata. So we have the files within metadata part of the table that are surfaced. So we can see that they are surfaced as chunks of offset ranges, and they map to partition values of like transaction hour from start of epoch. And they're all split into different ranges, per hour distribution of data. Then when we run some SQL, and important bit here is that the where clause has the transaction time for 1 day slice, so for 24 hours of data. We can go and see the execution of the query plan, and it shows that number of result files scanned is 24, aligning to 24 partitions of per hourly chunks of data. And then it's a join between 2 tables and things like that. And then if you run the same query without the time bounds, so not just for 1 hour filter, but for the whole thing, it takes a bit longer, but it's not very big data set, so it doesn't take extremely long. And in this case, it takes 112 data files to scan because it doesn't have any filter criteria, so it scans the whole range of offsets that are split into 112 hourly chunks of data in this case. So you can imagine if you're talking about infinite storage and like retention, we have 10,000 hours worth of data or 100,000 hours worth of data. Once we add chunking and partitioning and things like that, we can precisely target then different slices of it. The same when we do the categorization by other payload fields, like account numbers or categories of orders, things like that. Having that information and surfacing it allows us to query that data on Kafka in much more precise way. Now I'm handing off back to Tom.
He says, if it'll get past the demo slide. Yeah, there we go. So let's have a quick recap of what we've just seen. On the left-hand side, we have our Kafka. We're sitting here. What we need in order to make Iceberg work is a bunch of files. Kafka's not a bunch of files until we make it a bunch of files. If you saw the SSK box in there, that's what it does. It creates a logical representation of an S3 compatible file system so that Kafka looks like a bunch of files, but isn't. So we've not moved any data to make that happen. It's now just a bunch of files. On top of that, we then created our Iceberg metadata. Again, this is ephemeral. It's all queried it's all built by queries to Kafka metadata and built at runtime, which is pretty cool because it means the concept of a snapshot now doesn't become something that you create once. It becomes something you can impose based on the metadata that you can query back from Kafka. So we can actually have time travel moving in way past the need for expiring snapshots or anything like that. You can impose Iceberg concepts like snapshots as you like them whenever you like. So Kafka, S3 files, ephemeral metadata, processor. Right? What we've done is we've built up the ability to query our Kafka data estate without actually moving any data whatsoever. What's really, really amazing about this is there's zero lag. Soon as the data is available in Kafka, it's available to your Iceberg storage processor. It's guaranteed to be up to date at the time that your query was executed. The other thing Roman touched on was if you add an indexer to it, that suddenly becomes really, really efficient. I said we can impose our own metadata based on what we have from Kafka. We can also impose our own metadata based on what we introduce from external sources. So let's say you were to index your Kafka data as it was being produced, right, based on some field from a value. Let's say, I don't know, we're doing a bunch of retail data and we want product category, right? We can create an index over that, telling us which chunks of Kafka offset refer to which product categories, and we can mix that in with our Iceberg data. Now, when our query comes along, it doesn't just query the whole Kafka data set and filter out the stuff that we don't want. It can go, oh no, I only want this bit and this bit and this bit, and it suddenly gets really, really fast. Again, without moving any data. So if we go back to the beginning and had to think about what this single platform for batch and real-time would look like, what would be some great features of it? Okay. The same data, different interfaces. I think we've covered that one. That's what we want. We want to be able to use our best-of-breed batch engines alongside our best-of-breed operation engines, and we want them just to work with the same data transparently. We also want really simplified discovery and experimentation. As you can see from Roman's demo, all of the topics that are available in your Kafka cluster are instantly available to your Iceberg engines, right? So it's so easy for discovery and experimentation. And this one's a subtle one, but a really, really important one. What you get is consistency. And not just data consistency, you get consistency of governance, consistency of quality of service, consistency of security. What we do is we build a permissioning model once for our Kafka data, and that also applies to our analytical estate. Because we've only got one data source, anything that we do over this left-hand side is also applied on the right-hand side. I'm sure all of you guys have seen like one end of an ETL pipeline having a whole set of ACLs and routes. The other end is a completely different system with a different set of ACLs, and they're meant to be consistent, but they never really are. We've got around that problem by just having this one store of data, and that's where we put it. So we've created this unified system, and really it operates in these three kinds of paths. And the way in which it operates in these three paths is very, very important. So let's start from the red one, from the bottom up. The most important piece of doing this work for us, and the most important principle, is that it shouldn't affect Kafka operation. If you want to use data from Kafka in a real-time fashion, go ahead. Nothing's changed. It works in exactly the way it always did. Then we'll switch over to the top and skip the middle. If you want to run batch queries against your Kafka data, now you can. And you don't have to build and maintain an ETL pipeline to do it. The one in the middle is kind of interesting. What happens if you just want to do a point-in-time lookup, or you just want to dig out one record out of your Kafka? Today, you basically can't do that. Suddenly, by supporting an Iceberg protection and introducing indexing, we've got that ability. We're able to dive in and experiment with our Kafka data in a way that we wouldn't be able to do before. I'm not recommending it, by the way, but the other day, a customer asked me to connect, whether they can connect their ORM directly into Kafka. I'm not recommending it, but theoretically you could. So, the core idea is this idea of logical projections. That's what we want to do. We want to create a mix of stream processing and batch on a single source of truth. And that gives you a whole bunch of benefits. If you remember nothing else, just remember this slide, right? First off, we got zero ETL. That's probably the most expensive part of your data engineering business, and we get rid of it. Then you've got complete total access and one source of governance, right? Everybody who needs the data can now get at the data and do what they want to do with it. You then got consistency. There's no more analytical view and operational view because they're the same data at the same time. And you've got a very, very easy to implement batch data exchange. Who's ever built a Kafka pipeline just to feed some third-party customer or something like that, who just wants to, all they want to do is query a table once a day to dump the data out into their systems? What you end up doing is building a Kafka Connect cluster, and then you end up building another database just to stage it. It's, what we're doing is we're trying to challenge the creation of systems and intermediate steps for technical reasons only. And you get one security governance auditing model for online and offline. I keep banging on about this one. It's my personal bugbear. I do apologize, but it's important. And that would be the end of our talk. However, we can't stop ourselves. We're curious people and we keep on building. This talk has been about Iceberg, but it's a bit of a hoodwink for you guys. We said it was about Iceberg, but it's really about all logical projections over Kafka. So why stop at Iceberg? We can have Kafka as S3. No one wants this, by the way. No one's ever asked me, oh, I really want to access my Kafka data as a file system. We built it because you need it for Iceberg, but theoretically there may be some crazy person out there that wants it. On top of that, you could have Kafka as Iceberg. On top of that, you could have Kafka as a database, mix in a SQL engine, and that's aware of your indexing, and suddenly you've got something really, really powerful. You've got an analytics engine that's sitting on top of your operational engine. Coincidentally, these are the ones Stream-based sells. But and finally, why not have Kafka via AI? Any data analysts in the room? Oh, thank God. Good. We're going after their job. Right? As you can probably see, once we have a logical projection over our Kafka data, why don't we mix in a bit of MCP and LLM goodness and be able to say the customers that would normally issue their requirements to data analysts who would then go and fetch the data and manipulate it, why not let the LLM do that and we'll do that directly. The idea is that we have this single store and this single source of truth, and we create logical ways to work with it. And that would be the end of the talk. But no, it wasn't all plain sailing. If you really, I think I want to leave some time for questions, so I won't go into these in too much detail. But if you want to go and chat to Roman about the pains of dealing with Iceberg, please come and chat to us afterwards. And that finally is the end of the talk. So thanks very much for listening. And more than happy to take any questions you may have, and Roman will run around with a mic because he's the only one that's got it.
Actually, I have two, maybe we have time. So thank you for the talk, it's very interesting. Like the first question I have is that how do you map the data of the Kafka topic to Iceberg snapshots?
So a snapshot for us is just a chunk of metadata. So as long as you can fetch the appropriate metadata needed to build the snapshot from Kafka, then we can build it.
I understand, but basically if I unleash a Iceberg reader on that virtual Iceberg table and list snapshots, what will I see?
That is all dependent on how you want to build snapshots, but it's because there's a logical layer in the middle, you get to control that. So if you said, I want a snapshot that represents every hour of data going back to the beginning of the topic, that's what you'd see. If you said one, I want to every 10,000 offsets, that's what you'd see. There's no insert or creation or alter here. though we're actually working on an alter for when the schema changes. But there is you get to control that as the operator outside of the data manipulator.
All right. Can I ask one more, or because I don't want to take time away from the rest?
Go for it.
All right. So I assume that that would be like this virtualized kind of virtual Iceberg table would be read-only, right? If what happens if I try to, let's say, ask Spark to compact that table?
It would error.
Okay, so basically the catalog would say no.
Yeah, there's no compaction necessary because it's all been handled by Kafka.
I understand, just wanted to make sure that's like how it works.
Yeah.
All right, thank you.
It wasn't made clear enough, I do apologize. Yeah, this is a read-only projection. We don't write back into, because a write in this case of Iceberg table would be a write back into Kafka. And we can't provide the same kind of ACID guarantees that Iceberg can when writing back into Kafka.
Yeah, just a curious question. What kind of performance would I expect from this versus, the same data as Parquet tables or something in an Iceberg schema?
So dodging the question completely, it's entirely dependent on the data shape and data size. Have to always have that caveat. I should just have that written across my forehead, I think. However, we did mention the indexing is the key part to this. So depending on your query shape and the data shape, if it matches indexing really, really nicely, you're not going to see any performance difference. In fact, you may see a performance improvement versus the kind of partitioning, the static partitioning that's there on Iceberg. There's the big elephant in the room, and I'm just going to address it. We're row-based in Kafka, and there is no way of getting around that. So as you saw, we're surfacing this data as Avro, which is a row-based format. So if you have a lot of projection to do, then you're going to see significant performance increases from using Parquet in over Avro to do that. Now, to counter that, I get asked this a lot, so I do have a counter for this. Kafka topics and Kafka messages don't tend to be very wide in the beginning. So it's not like we're taking hundreds and hundreds of fields, right? And you have to address those every time. Typically, the data sets that you're working with in the analytical realm for Kafka are multiple joins across fairly narrow topics. So you handle the speed up due to projection by knocking out joins rather than by being able to read individual columns out of the data itself. Does that make sense? I feel like it kind of makes sense.
One more question. Then, thank you again very much. Give another applause for those speakers.
That was good fun.